divided at Insights, Programs, and Tech Forum. Insights consist of position papers and white papers. Then we have our magazine, Visions for Europe, that is printed quarterly. And of course, newsletters, and as I mentioned already, EU tenders. We have a social media support programs, digital transformation support program that I'm responsible for. And we do lots of awards. For example, SDG award, where we for each goal we give away 10,000 euro. So 17 goals makes 170,000 euros that we give away for just the SDG award. And of course, we help companies to become climate neutral. In regards to Tech Forum, all our members are getting a virtual booths. We help them with the virtual expos. We currently creating digital and physical events, and we help our clients or advocates to also create and manage their own events. If you want to engage more, please get in touch with me, and or also contact Marcus Wiman, who is Director for Partnership and Institutional Cooperation, or Federico Di Aredo, who is a Director for Membership. So this is a very, very short overview of EU Tech. Good morning, ladies and gentlemen. Thank you for joining us today in our digital event. I'm sure it's going to be very interesting. We have a great topic, the role of 5G in smart cities. So it's a pleasure and honor today to introduce our panelist. Joe Magnani has 4 decades experience in telecommunications, both as a solution architect and in business consultancy role, specializing in 5G, machine edge computing, and Industry 4.0. She has BA honors in IT and master degree in business innovation with electronic business from University of London, with specializing in factory automatization with the industry IoT. She has been working for Verizon for 15 years in Europe and based in London, UK. Our next panelist is Mika Skarp. He's a senior product manager from Kumokor. Mika is awarded telecom network technologist, entrepreneur, and executive, a lead engineer at Nokia, both in Finland and Silicon Valley. Mika was the founding president of VMAX Forum. After over a decade developing groundbreaking technology-enabled business models for Nokia, including GSMA, award-winning Village Connection program, Mika also consolidated his learnings and patents to launch Cloud Street, the world's first network slicing platform. Mika is active in telecom industry as a writer, commentator, and mentor focused on digital transformation in support of net neutrality and common free and open internet. And our third panelist is coming from Bosnia-Herzegovina. Aleksandar Mastilovic is a recognized international expert in communication with experience in technology, academia, and government sector. Mr. Mastilovic now works as an independent consultant for various international institutions like UN, UNDP, ITU, GITS, IAAA, WBAF, and on topics on telecommunications, 5G, telecom market analysis, smart cities, digital transformation, and public administration, and SMEs. Focus on bridging the gap between academic innovations and the market, converting patents and scientific achievement to entrepreneurial action. At the beginning of 2017, he became a member of governing bodies of the world's largest professional organization, IEEE, the Institute of Electrical and Electronic Engineers, which is still members of several working groups and committees. He is a senator for Bosnia-Herzegovina at the World Business Angel Forum and ambassador of Bosnia-Herzegovina in the Global Blockchain Association. Dear audience, I would like to remind you that you can ask the questions in a chat function. Please use a privilege to do that. Mika, I just made you presenter. So at this stage, we will have a Mika to deliver a keynote speech, which is a deep dive into today's topic, smart city role in 5G. Mika, I'm delighted to give you microphone.
Thank you, and good morning from my behalf as well. A couple of words that's where we are coming from. So, what is the kind of a context of my presentation? So, we have a company called work for a company called Kumukor, and we are a research-driven organization. We are actually working very closely together with the Aalto University in Finland. Aalto University is one of the largest technological universities in North Europe, and there our role has been and is to support the use case research. So we don't really kind of do applications ourselves. We do on mobile networks. We do 4G, 5G, and now also 6G research things and the concrete networks. But we don't do use cases, we don't do applications. But because of this role, we see a lot of different things. So we are part of the roughly 6-7 EU-funded research projects all the time. So this is where we are, or where my views and comments are coming from. That's the kind of the background. So it's end-to-end approach, kind of looking at from the 3GPP perspective what can be done, and then utilizing the 4G, 5G, and then also in the future 6G technologies. That's the context of my speech. So what is the smart city? So that's an buzzword that has been around for quite a long time. And in my opinion, it's really nothing special or nothing kind of revolutionary thing. It's basically an automation of the society. So now, when moving forward, especially in these kind of difficult times that we are going through, so I would say that it's coming more concrete and accelerating the many of these kind of good initiatives that we have. And the points that I kind of see very important are energy efficiency. So we all are suffering the increasing energy prices. So all those kind of things that we can decrease energy consumption makes sense, and they are kind of a project that will be funded. And if that requires automation in the city, so then I think it's a part of the smart city thing. The other thing that is more really important, equally important with the energy is the security. So that when we increase the level of automation in our societies, so it means that we are coming more and more depending also the technology, and the security needs to be there. That's a very kind of a crucial thing that we are not afford to fail. And then it's also the fact it has been and it will be a very complex business environment that we have. We have public organizations, private organizations, small enterprises, consumers, and so on. So getting that right, it's not easy. But as said before, then the environment where we are at the moment, it's accelerating the development for sure. That's what's going around with the smart city. I typically always want to take a look at that. What's the history? What is the legacy? I've been looking at these things since GSM. So the technologies to provide smart city, they have been used for decades. So we have had fixed networks. We have had proprietary radio networks for some applications, so low bandwidth, low frequencies, and so on. And then the kind of the first bigger wave was on GSM text messages, and then GPRS data connections. Good example is the automated energy gauges or energy meters that are that are distributed around the globe. And so far, the use cases, it has been kind of collecting simple data from sensors and then using that for something billing purposes or something fairly simple. Then switching on and off maybe some motors or pumps and so on. And then obviously also for the payment transactions. So that has been probably the most groundbreaking technological change that we can actually do small payment transactions. And similar kind of disruptions we can foresee to happen in the future also for the other areas of value chains. And then obviously surveillance cameras, that has been and that has been a big use case, and that most likely the importance of the cameras will increase, and that data will be then used for many other things. So that's the legacy what we have, and now when moving forward, these are the things that we kind of we are building on top of those things. So what are the requirements? That what do we need to have? What are the important things? So the power consumption is a thing that we can't overestimate. That it's and now power consumption meaning in the city wide, that it's not only the power consumption of the mobile network or technology what we are using, but how we can reduce the power consumption in our societies. And it's a short-term thing, but it's also a long-term thing. And then also the lifetime, when we think about building an infrastructure in a city, so the lifetime is decades, maybe, and hundreds of years. So also that has to be taken into account when thinking what kind of technology can be used. Security. So the more data we use to run our societies, the more important the security aspect is. And then the more we rely on real-time data streams, then it's also the means that there are no place for error. So we have to trust the system. It has to be obviously affordable from the capex and opex perspective. And then the big thing is that there are hundreds of different kind of applications. So basically, we need to have a system that can support many different kind of applications. So from the network perspective, those kind of applications that are low in capacity, but then on the other hand are high in capacity, downlink heavy, uplink heavy, delay sensitive, and so on. So basically, the one network needs to be capable of doing it. And
Mika, I'm sorry to interrupt. We have more, two to 3 more minutes to finish, please.
Yeah,
thank you.
I will get to the point. So that's the thing. So now the PEEF. What is then the 5G? What we can do here is that it's fully virtualized. So basically, it's a low in capex and opex. So meaning that there is no proprietary hardware needed. So that's definitely a building block that we can count on. It can integrate it with the existing IT infrastructure using with an advanced features like a 5G LAN. With the slicing, we can provide a different kind of support for different kind of applications from a one network. And then we have a huge variety of different frequencies that can be used in the technology. And then if that was the PEEF, so then this is the BAN. That's a new thing because of the frequency kind of a regulation liberalization. We have not only the public networks available, but we can actually build a non-public networks for limited coverage areas. So these non-public networks, they can be run by the city or some other organization or an enterprise. It can cover one warehouse, or it can cover a larger geographical area like a city. The difference between the public network and non-public network is that the non-public network is typically not focusing on the billing, so it makes this running the network significantly easier than what we have seen on the public network side. So running a 3GPP 5G non-public network is basically like a Wi-Fi with a booster. So easy to use, low in cost, and then can serve several use cases from one thing. And that's, I think, it's also taking into account the whole thing, that there is a little bit of an urgency to increase the automation. We have a technology to do it, and then we have also the frequency policies to support to going there. So that's them I think a promise and a very kind of a bright future of accelerating the smart city development. Here in short my information, so if you want to be in contact, but I stop here and leave that arena for questions.
Thank you, Mika. Thank you so much. I really appreciate that. So I'm very excited to go to the questions. Again, I see already interaction is going on at the chat. That's fantastic. Okay, so first question for Alexander. What is so specific for the 5G compared to the previous mobile network generations?
Okay, thank you for the question. Actually, 5G is very, very interesting, and it's not the first time actually in one continuous journey of improvement in mobile networks that we have completely changing directions. That was the first generation where we actually had finally access to mobile internet. The things changing, architecture is changing in 5G, because this is the first generation mobile cellular systems that which actually is not focused on human-centric services like voice calls, messaging, or internet access. This is the first time that mobile system is focused on machine-type communication. Actually, Mika talked about that. It's interesting that actually we are looking to how to deploy many microcells, not just regular macrocells. What in 5G we are trying to deploy enormous number of microcells, something similar density like Wi-Fi routers almost everywhere around us, and trying to push these microcells to work in millimeter wave communication technology to provide a last mile high performance access for end users to be able, for example, to stream 4K video and to actually to save us a lot of money. What we plan to invest in fiber optic, but on the other hand, also to be able to support millions of sensors one relatively small area. It's not possible in 3G or 4G, because even if we are talking about just a few kilobytes of transmitting, we are talking about complexity of controlling protocols in mobile networks is much more difficult to control 1,000 devices asking for 1 megabits per second compared to one device asking for 1,000 megabits per second. And it's a very important perspective, because if you have millions of sensors trying to transmit at the same time, they are competing for resources, and there are a lot of collisions in the media, and we have a lot of requests for retransmitting, trying to push that to the system. Of course, we are avoiding to create some kind of scheduling, because we also need to use additional resources in controlling part of the system. Regular users thinking only about access part. Okay, you have internet access, but beside of that, there is a lot of channels in controlling protocols trying to keep. It's very important to understand these significant changes in architecture. Smart cities are massive deployment of sensors, everything about that already. So theoretically, in one medium-sized city, maybe 1 million people, we can talk about billions of billions different sensors. For example, supporting self-driving cars, smart metering, smart parking systems, smart public transportation, smart waste management, etc., etc. Many different applications, smart cities. In perspective, maybe for 10 or 20 years, we will have billions of sensors in one just mid-sized cities, and it's a huge challenge for mobile network systems and for future evolutions, of course, under the umbrella of 3GPP and other professional industry academic organizations which work on and recommend.
Thank you, Alexander. Just to let you know, you already have general questions, 2 general questions, 1 question for, actually 3 general questions, and 1 questions on security for Mika. Thank you all for questions. We move on. Joe, welcome. So in regards to 5G, to what extent do you work with the customers to understand their business issues, processes, and desired outcomes, and work out a business and solution architecture on their behalf?
Yeah, so essentially, if we look at what 5G can underpin with respect to the requirements for the very demanding applications which are in the domain of both private and, in this case, public applications for smart cities, we always have to look at the end user outcome. What is the outcome? And in most cases, it's about saving costs, efficiency, and integration, and of course, security, as a lady from the audience has indicated here. With respect to security, I'll reiterate immediately, we have to basically go from implicit trust model, where we used to design trust implicitly in the network, to a model of zero trust. We have to integrate it from day one. It is absolutely compulsory. In terms of looking at, the actual end user outcome, we need to understand what the end users and the end providers of this service are looking to do, because 5G just on its own does not inspire my customers, and I work with a lot of industrial customers and those that want to work within different ecosystems. So we have to look at the end user applications, how they work, how they can be complemented to work with an underpinning technology such as 5G, how close to the users it needs to be so that we can actually provide efficient and optimized response times. Does that go into a cloud? Does that go into the edge? Who do you work with? Do you have to work with a cloud provider? Can you do it yourself in a private data center? So there are so many design considerations, but first of all, we have to let the end users and the customers talk about what they need. And that is my starting point. I hope that answers the question.
Thank you, Joe. Thank you so much. Mika, what's the most important 5G use case in smart cities?
Yeah, that's a question that I would say comes up every single time. That what is the kind of a killer application? There is no killer application. So there are hundreds of different applications that different organizations will come up. So then kind of a high level common denominator is sustainability, or as Joe said, that that having a saving savings for the end user. So that needs to be there. But just giving examples that what we are doing, or what we have done in the past. So for example, a temporary network for fares that you can do, and mobile point of sales terminals covering the whole fare area with a one temporary base station. That's a very good example of that. What kind of savings can be done. The surveillance cameras can be installed in the places that would be otherwise impossible to do, and then also reducing the amount of labor. So one of those big themes in Europe is that we are getting older as a population, and the labor amount of labor is reducing. So automating things and taking the networks to the places that they have never been. So for example, and trains, that when you have a problems underground, so that how can we help there to automate that? We don't need to send somebody diving into the pipes and cleaning them. So those kind of things, but there is no single killer application for the smart city.
Thank you so much. So similar question to Alexander. Why is 5G so essential for smart city applications?
I would like to discuss this big truth, actually, what Mika said, that we don't have a killer application. And that's actually the problem. Because all of us who are related to telco industry, we are aware that actually telecoms around the world are struggling in creating sustainable business models right now. And 5G is not something what telecoms find profitable right now. We are talking about investments of billions of euros, dollars, whatever, in the infrastructure. But actually, we are not doing that because of higher speed for internet access or something like that for people. Because if you just remember a little bit a decade ago, it was very clear 4G, because with 3G you cannot play real-time games, for example, or watching high-definition videos, etc., etc. So, from the perspective of users, users were ready to pay more for more quality internet access. For 5G is not clear. Because we are waiting for application. This is the first time actually telecom infrastructure going in advance. If we're thinking about capex and opex for 5G, we are talking about something what is at least 10 times bigger comparing to 4G, because besides the regular microcells, we need to deploy 100, at least 100 higher density of microcells to establish the real 5G network. For that, we need XQs, self-driving cars, for example. The idea to have low latency, ultra reliable communication, and processing power on access side of the network in base stations instead of core network in the telecom centers is something what is the vision. Maybe we were waiting for 6G for that, but actually we need this kind of killer applications, not only one, maybe few of them. Spend billions of dollars infrastructure. If you read a little bit what's going on, actually, the global idea, even European Commission discussing about that, to start content providers and services providers like Google, like I don't know, Amazon, internet infrastructure to telecommunication infrastructure to help telecoms to continue building infrastructure. This is something what I don't like, because we are killing net neutrality. Actually, the telecoms globally have a lot of problems to establish sustainable business model to continue investing in telecom infrastructure, starting from 5G, but also in the future.
Thank you, Alexander. Thank you so much. Next question goes to Joe. Again, in regards to 5G, what do you offer? Do you offer fully integrated IoT-based application solution, including connectivity, or just application part?
So this is a very interesting question, and also I think it's not sufficient just to offer an infrastructure which is underpinned by 5G, which provides the technological advantages of working with demanding applications that need low latency or network slicing. We need to provide additional combination of connectivity for the Internet of Things, monitoring the sensors and other application services on top of that infrastructure to help customers solve their operational business problems. So we need to enable the connectivity, and that's underpinned by 5G, and also connecting the sensors. We need to be able to provide additional services such as collecting and analyzing data, and then adding further decision services which are necessary for these connected solutions. So a lot of this is not, somebody asked the question here, well, 5G is typically owned by the network. That's not strictly true anymore, because you've got the public 5G providers, but you also, with legislation being relaxed, and I see it across the world, especially in the Europe, Middle East and Africa, where I work, legislation is being relaxed such that you can actually construct, companies can actually build their own private 5G infrastructure now. So there will be a merging of public and private into working, but you need to have this other plethora of services behind it that actually looks at a number of different other things that manage the applications, that look at connectivity services. It's not enough just to provide 5G.
Thank you, Joe. Thank you so much. Mika, you mentioned many times non-public networks. What's the main driver to use non-public networks?
Yeah, I think this continues nicely what Joe just said, that now it's possible to do those kind of non-public networks from the frequency perspective, but also from the cost perspective. That the price of the base stations has gone down, and also the core is because of it's fully virtualized. It's a significantly lower cost than it used to be. Just kind of giving the number is that when I started in the business, the minimum configuration of the GSM network was something like 25 million euros, and now we can do the basically minimum configuration of a couple of thousands of euros. So that's the but the driver there is that the mobile operators, their main customer, their main line of business is enhanced mobile broadband. So they are serving consumers. So making sure that we have access to the Netflix, and we have access to these kind of webinars and things. So when you need something different, then you start looking at the different connectivity options. And then the non-public network means that you can build the coverage into the places that where it's not right now. So you control the coverage completely. You control who can access the network, what kind of profiles they have. You don't need to care about net neutrality rules. So you can provide a completely different kind of profile for a sensor than for the security camera. You can then ask that where to put the coverage and what kind of a performance is needed. So those are the drivers that makes the thing that you want something that the mobile operator can't, or they are not delivering to you. So you build the network yourself, you control it yourself. And then these non-public networks, they don't need to be connected to the internet at all. So then also it will then add an additional layer of security on the network.
Thank you, Mika. Alexander, it would be very interesting for our audience if you can make a short brief on what is the current state of G5 launching in the world?
This process is actually very active right now, maybe a little bit slowed down by pandemics and the current situation in the world globally, because we are facing some kind of economic crisis. So the process is slowed down but not stopped. Just few countries actually launched significant progress in 5G that I can say that 5G dominates as a mobile network. Maybe the global leader is Switzerland. I think almost 90% of mobile network is already 5G. Also, high developed countries like United States, Germany, Nordic countries in Europe, and some other countries also deployed significant percentage of 5G base stations and covered the area. But China, of course, because that was some kind of national strategic project to support Huawei in that case, and you know that actually Huawei stopped to expand more in the West countries because of security reasons. Also, what significantly slowed down at some point further progress of 5G, because at that point Huawei was the technological leader. Then, of course, response from Nokia, Ericsson, for example, as alternative vendors comes, and deployments in USA and Europe continue at some point. But as we discussed earlier, this process is not so intensive as we expected, because we still suffer of lack of real applications which require 5G as the only one solution for deployment. Most of applications we are using right now can pretty good work on 4G. And that's another case also to slow down this process. Okay, some countries did a great job, but we cannot say that 5G launching is going as we expected, for example, a few years ago, because everybody discussed about 5G, expected a lot of things, but it's not happened because of 1 million reasons. So this is some global picture without going in deep details. But let's say that maybe only a few countries using 5G more than 50% of total number of base station and coverage.
Thank you, Alexander. Thank you so much. Joe, would you be looking for partnership to build that connectivity and management, and for providing continuum of add valued services, such as collecting and analyzing data?
Yes, absolutely. I think it's necessary. I think just to provide an underlying connectivity and not to provide the continuum of value-added services is really not doing the end customer or the end solution provider justice. You know, I think it's necessary to provide a fully managed service, a portfolio, to actually provide a good and seamless solution.
Thank you.
Yeah.
Go ahead, Joe.
I was going to say, no, this is it's very important to look at end-to-end projects, and to look at either, providing partnerships for this, but fully cohesive partnerships. I think that's very important.
Thank you, Joe. Mika, again on non-public networks, I guess that's very interesting topic by looking at public chat as well. So what's the difference between non-public network, if you're explaining to somebody who has no knowledge, or you're talking about potential client, and if you can touch the point on the cost of running non-public networks?
Yeah, technically, non-public network and public network, they are using the same technology, and that's the kind of the reason why the non-public networks can be so low cost. So so technically they have the same hardware, they have the same software, and then they can use the same end devices. And this is basically very important, what the same end devices can be used, because then we are gaining the economy of scale, things that there are millions and tens of millions of devices manufactured, 5G devices manufactured every month or every day. So it's a very big thing that those technically they are sane. But then these non-public networks, they are simplified. So as said, typically the billing is not an issue, because you own the network yourself. You kind of use it for your own purpose, so you don't need to take care of billing. So if you look at the cost structure of then a public network operator, so the marketing and the customer care billing, that's the major, I don't know, 2/3 or even more of the cost what you spend. All that is gone in the non-public network. So you will actually gain. You will use the volumes. You will gain from the volumes from the public network side, and then you are using it for your own purposes. So basically, what we are seeing today, and what the projects that we have done, so the non-public network cost is on the same ballpark with the Wi-Fi. So, but it's a significantly